Thank you all for coming here. We're very happy to have a bunch of people who are interested in learning about open source education with us. I'd like to thank Jonathan Apavu and Aran Krieger, who will be speaking about the education efforts that are underway at BU and in the Open Cloud testbed. And I'd like to thank Hima Varadi, who is our Red Hat conversation lead, who's going to keep things interesting and exciting and hopefully encourage you all to participate live with questions and comments as we go along. Let me start by introducing Aran. Aran Krieger is the director of the Cloud Computing Initiative at BU and also leader of the Mass Open Cloud. For those of you who've had any experience using that, it's a very exciting live data center where students and researchers can do active work with infrastructure that's supported and maintained jointly with BU and Red Hat participants and other participants from other places as well. He's also a co-director of the Harari Institute and the Red Hat Collaboratory, or the Red Hat Collaboratory part of the Harari Institute, and a very active collaborator with the Red Hat Research Group. He, before coming to BU, spent 5 years at VMware working on vCloud. And before that, he was a researcher and manager at IBM TJ Watson, leading the Advanced Operating System Research Department. And before that, we've gone back far enough in time. He got his PhD and Master of Science degrees at the University of Toronto Electrical Engineering Department. So with that, I'll hand it off to you, Aran.
Thanks, Heidi. So I've known Jonathan since graduate school. Well, actually, his first day was my last day, so we overlapped for about 20 hours. Then he joined me at IBM Research. We worked on K42, Linux, a bunch of hypervisors. Jonathan's actually one of the most amazing OS developers I've ever worked with, brilliant researchers, and one of the most out-of-the-box thinkers. In fact, the only reason I actually started on the cloud path and started vCloud and then the MOC and all the work we're doing together with Red Hat is actually he convinced me of the potential of cloud, or what we also called it then utility computing, back in 2004. So I think you've all heard, or many of you have heard about the MOC, where we're going with the Open Research Cloud Initiative, Operate First, and these are really exciting things. What Jonathan's going to talk about today is his ideas on how what we've been building can be used to fundamentally transform education in the same way that open source has transformed operating systems and much of the rest of software. Now, honestly, while Jonathan involved me in some of the early brainstorming, I deserve no credit at all for what he's going to show you. And I actually didn't realize he put me as a co-speaker, so I thought the only thing I should do is actually introduce him. I hope this presentation excites you about the vision and potential of using the technology we've been building to transform education in a profound way. I do want you to realize that while Jonathan will make it look easy from my experience with him, everything we're talking about here is very fragile, and only somebody with Jonathan's skills could put this together. It's going to take a lot of investment to enable somebody in math, physics, medicine, or even the humanities to transform the way they teach and the way they impact society in the way what I hope Jonathan is going to show you will show how we can transform how we teach operating systems and systems to computer scientists. But I think it's got an incredible possibility. And with that, Jonathan.
Thanks, Aran. I guess just, standard things. I assume my sound is okay, and I assume everyone can see my slides. I do suggest that you put the slide view into a relatively large window or full screen if you can. But before we get going, something like this was probably crazy to start down in the first place, and I owe many thanks to many folks, and I'm going to spend just a couple of minutes to point a few out. So first, I really want to thank Dr. Mark Cravella, who's a professor here in our department, who really created some just exemplars, pioneering exemplars, at least from my perspective, for the use of Jupyter and his commitment to excellence in teaching. He's been, we'll look actually at his book a little bit and how it's evolved and how long it took him to sort of evolve to the point where he's actually dropped using a textbook and is able to use the infrastructure that he's created. And that was very inspirational for me. And straight up, right? I'm a bit head. I avoided learning Python and Jupyter for as long as possible. So it was really something for me to see, wow, actually the world really could benefit if we sort of embrace these kind of new ways of using things while still being able to hit home on how things work under the covers. So hopefully I'll convince you that we're moving towards that. But the other set of folks that I really want to thank are the Operate First team. Like, I have to say, again, if I can't see the processor, I usually shy away from everything. And at first I was like, I'm not using somebody's stinking cloud stuff over there. I've sort of developed my own cloud infrastructure anyway. But I have to say the Operate First team has just done an amazing job in building an experimental environment where I can try things out completely built out of open technologies. And this actually is such a fundamentally important thing when it comes to education, and hopefully I'll convince you of that why. And I also really want to thank them for suffering all my silly questions as I was trying to get things working. I also want to thank Heidi, Hugh, and Sanjay Arora. So much like Operate First, the Red Hat Collaboratory, again, I was, to be honest, very skeptical. Oh my God, are you telling me that we've got this corporation coming in and I'm going to have to go spend my time to, as happened at IBM, the egghead has to be rolled in just so that we make sure that we all look like we're doing useful things. And I have to say, it's been completely the opposite. They have really supported me and helped me realize what we can do by adding the power of open platforms behind academia. And Sanjay, thank you so much for letting me steal time out of our research meetings to have you babysit me learning IPython. And I guess, okay, one last thank you, and then I'm going to get going. I really do want to thank my good friend and colleague, Oran. He's always been really great at making sure that I know where there's a very long piece of rope. And, I've managed to only hang myself a few times, but thanks, Oran. But more seriously, I also want to thank him for having the stomach to do what needs doing, because I have to say, I don't know that many academics who could have spent the number of hours sitting in meetings to get something like the MOC and the Collaboratory off the ground. And I think this kind of bridge and everything that I've benefited from, my graduate students, and I hope my undergraduates, I think it's really quite amazing. Okay, so my two big disclaimers. This talk itself is a demo. And with any luck, the number of bugs and things that we run into will only be small enough that you'll realize it's all real, but won't actually have me just having to go back to a chalkboard. The other thing is, I want you to remember that I ended up in academia because I didn't want anyone to get the false idea that I was actually capable of doing any real work. So remember, this is all spitballed. Okay, so this talk is going to break down in approximately sort of 5 pieces. So first we'll have a quick discussion of open educational resources and what that is and what that sort of the little bits that I know about how things have been evolving. And then we're going to dig down into sort of the small picture. And we're going to talk about my effort to build a computer systems education, surprisingly, out of tricks that Jupyter has. And so really there'll be three sort of aspects of using Jupyter in the context of all the other things that Jupyter will start to unfold for us. And then we'll spend a little bit of time talking about the road ahead and what's necessary. Okay, so let me switch over here. So I've got all my windows in the right spot. Okay, so, okay. So yeah, great. So I don't know how many of you may or may not know, but I think all the way back to about at least 2009, there have been efforts by legislators in response to realizing that the publishers just have this huge stranglehold. You know, like when we talk about college debt, what are we actually doing to try to ensure that things like just textbooks don't overwhelm the costs? And yet, legislators have had a very hard time trying to get affordable open book acts passed and so on. And I think around 2018 or so, they managed to squeeze out about I think it was about $5 million worth of funding. But keep in mind, that's compared to the billions of dollars that the five major publishers have at this work. And just to be clear, just because we went online, things haven't changed, right? Publishers encode keys in their books now just to incentivize and make sure that professors are using the latest versions and their students have to get into their platforms. And then there's this whole thing that what started to evolve. So in 2018 and so on, we have seen movement, which is great. So there are things like OpenStax, which is movements to build free textbooks. But actually, it's sort of a little weird. You know, the publishers, very much, no big surprise, have a very cathedral-like model, right? They invite authors and everything's blessed and all the actual underlying material is closed. But it turns out that when this move to free textbooks has arisen, it's also in some sense replicating that model. We're seeing invitations for authorship, we're seeing that it is at least peer reviewed, but it's then being very much the underlying mechanisms are all closed source. And even more perhaps surprising is we haven't actually even established higher bars for ourselves. We haven't sort of said, hey, what about innovative computational platforms that could be integrated into our educational process, especially for STEM-like subjects? So I think it's surprising to see that actually the free textbooks are actually very much turning into the attempt to create cathedrals. And that's very hard to think about those competing against these established ones that the publishers already have going. Now, I think we've seen this before. And I think for those of us who have been working and building software and re-architecting the world and have gone through this kind of sea change and sort of shaking up the world between using cathedral-like models, between cathedral models and things like a bazaar, where we sort of say, hey, you know something? I know this hierarchical top-down world is sort of provides control, but actually, if we empower folks, we can do a much better job by letting collaboration really sort of take hold of evolving our software bases. And I think that we stand at a very interesting crossroads where the same could be for educational resources. So I'm hoping that I'm going to show you that actually platforms and our technologies and our approaches to letting digital content and artifacts like software be open can actually be equally applied in the domain of education. And in that domain, we actually can do way better than just making free textbooks, because we can actually codify interesting usage and integration of live content powered by open cloud services. And again, remember, I'm a professor, so I can certainly drone on, but do not hesitate in stopping and engaging, because, you know, that's totally cool. All right, so let's actually, so on the left here is this stack that I'm sort of proposing. And what we're going to actually be looking at is my attempt to cobble stuff together to redo one of our core introductory systems classes at BU. The way this is going to go down is I'm going to start building out pieces of this thing on the left with things that we have existing today. So on from the open data center perspective, part of the MOC has been this push with the Massachusetts High Performance Computing Center, our own data center, where actually it's not owned by a corporation. It's multi-institutional and public ownership. So all the way down to the real estate is being founded on an open ownership model. Great. So that's going to be our terra firma that we stand on. And no big surprise, it's going to turn out that the Linux operating system is going to be the foundation for everything we build on top of this. So the first layer that, you know, is going to exploit Linux is bridging ourselves from the hardware resources to how we're going to actually enable cloud platforms on top of this. And organizationally and technology-wise, this is where the Massachusetts Open Cloud comes in, and how every aspect of building cloud services is going to be founded upon the use of OpenShift. And that's going to be our bridge from the hardware to the kind of services that we're going to put on top of it. And as I said, to my surprise, it's going to be Jupyter that I'm going to actually use as the skin and the delivery model for how I build varying aspects of educational material. And perhaps maybe no surprise to all of us, Git and repository control is really actually also going to be the linchpin for enabling the social model and the control structures and the revision structures for how we're going to collaborate on this new type of educational material. So then what we're going to do, or actually maybe how we're going to start this conversation, is looking at some exemplars, two in particular. One that was done by my colleague, as I mentioned, Dr. Crovella, over the years to develop just fascinating content for a linear algebra, CS linear algebra class he teaches. And then the work that I've been doing to establish this set of material called Under the Covers, The Secret Life of Software, which breaks down both into lab manuals, lecture material, textbook material, all sort of in an integrative live fashion. Okay, so, you know, how did I get here other than sort of being, having a few screws loose instead of just sort of droning on in my lectures from the phone book, is I really felt that our computer systems class, which was using a traditional book, actually a very, very venerable book developed at CMU, wasn't really meeting the needs of our students. And it was also the infrastructure is aging with the accretion just many, many sites such as Chegg and others that literally allow students to go to websites and, you know, get help with their assignments. And I was really looking for a more modern approach that could be really innovative for us revamping our curriculum. And it turns out, based on Mark's examples, I stumbled into Jupyter as really a potential way to unify things. So just a quick background into this class that we're sort of building this infrastructure around. It's been about teaching, so it's called CS 210, which is Introduction to Computer Systems. And I have to say, teaching people their first touch at things beyond being given a canned sort of GUI of a programming language like Java or Python and sort of being given little things to algorithmically think about to, hey, how do things actually work? Where is the assembly code? Where is the C code? What is an operating system? Your first attempt to really get your Unix prompt for the first time. It's extremely rewarding. However, it every year becomes more and more difficult as the semantic gap, you know, that bridge from the first iPad now that you got handed to at a table to keep you from, you know, disturbing the grown-ups, to now me telling you, actually, you know, that funny little dollar sign and that green window and those funny texts, that's actually useful for you to learn. It's a very difficult thing. And I've found that we really need a new approach to the computing environment, one that can get stripped down as needed and yet still be rich, that lets an instructor fluidly move a student through all these layers while making sure none of it's fake, right? So I've actually seen folks, again, no disparagement, because we each are trying to figure out what's right. But I've actually found folks who teach assembly programming, like I'm going to actually show you a little bit, in Jupyter. But you know what? What they do is they create this beautiful kernel on the back end where you end up typing an assembly fragment, you hit return and it spits out an output. Really? So that's great in sort of giving you some basics of what assembly programming is, but everything you learn there is going to be so disconnected from the realities that it might as well just be another theory class. And so I really want to make sure that we recreate the same environment that many of us grew up with, which is this idea, I'm not going to turn my camera, but on my desk is actually a good old VT220. And on that VT220, when I sat down for the first time, was an entire world that was cryptic. Like there's a great quote, right? Like the Unix is a very simple system. You just need to be a genius to understand its simplicity. So you have to grow into understanding the power of these ideas and how they fit together. And I want to make sure that that still is possible. Okay, I've already been blathering on a lot, but let me, I'm gonna just keep plowing forward. But if I'm going too fast or if anyone wants to stop me, don't hesitate. Okay, so now to the core stuff I'm hoping to excite you by, but remember, I've got a small little brain, so maybe I'm just impressed by things that everyone already knows, but I really found that these tricks that Jupyter have, it was really quite interesting. So I think that Jupyter and evolutions beyond it and its competitors and so on, it can actually provide for us a unified environment where a web browser is all that's going to be necessary to get your foot into the door of a broad set of educational material that can teach you all the way from assembly programming up to data science. And that Jupyter can be a binding glue for live lecture material, for authoring and deploying interactive textbook material, and for deploying self-exploration kind of lab environments where the students have their very own personal Linux box to pull apart. So the three pieces to this story.
Jonathan, just before you jump right into
Yep.
Jupyter, I think there was one question in chat, although I believe your sequence slides are probably going to answer that. But they just want to know, is this something similar to our books, which are similar, like the statistics that you have inside of R, as well as the other packages that R provides? So is Jupyter something as similar to that, or is it something quite different to that?
Great question. So I'll be straight up, right? I am an OS kernel developer, and I am really more focused on the properties that Jupyter is providing. And I certainly am not well versed in all of the different environments that have been evolving. But as we go through this talk, and I can give you some actual live demonstrations, I think you'll see what we're really talking about is not so much the IPython interface. We're talking about the ability to publish and integrate Unix mechanisms into a live set of material and for it to be repository controlled. So I don't know our books very well, but it's actually the full stack of software that I would believe that our books rely on. That's actually what we're focused on. And the actual syntactic construction language-wise, I believe we should make sure that we go whatever way is effective. But bear with me, and as we go through some of these, if it doesn't make sense, just stop me and say, hey, you're at that prompt. What does that mean compared to this prompt? Okay, so the three pieces that I think I found interesting is that this thing called Jupyter Book. Now, terminology-wise, it's such a zoo, but I'm talking now about a platform, which we will look at, which allows us to do high quality static publication of material for authoring textbook like content and pushing it out on websites, but for it to be very high quality. Then the next is actually using Jupyter and the environment to create presentations that aren't just PowerPoint. Okay, and we'll look at that, and that's actually going to use something called the RISE extension. And then finally, that Jupyter itself is in actuality a desktop environment for a container, and that actually brings about a whole lot of power in constructing classroom material. Okay, so let me see if I remember here. So, and again, I'm going to hit this point again, right? Git is so important because it is going to be that every one of these document formats in the end is going to be publishable and repository controlled, and it's going to power and empower all those kind of processes that other people outside our worlds, like in the publishing world, don't have the power to do, to allow for collaborative authoring and for content tracking and for community participation, and for that matter, easy publication. Okay, so let's take a look at this first thing that I actually found quite remarkable in terms of the value as an author. So there is this project called Jupyter Books. Now, Jupyter Book is a set of, oh, sorry, hang on, I gotta be a little careful here. I'm not still perfect with how I navigate all my scrolling here. I'm in layers of scrolling. So Jupyter Book is a series of packages that lets me author content in notebooks, and not me, obviously, but the broader community, and then generate from those collection of notebooks this kind of high quality static, or at least partially static, HTML published material. So, this is actually the Jupyter Book website, and we can see various pieces that it integrates. All of the things that you would expect inside a Jupyter Book, like high quality markdown and support for MIST and support for LaTeX, all the pieces that we can use to make our notebooks sort of a nice data narrative can be converted into these really nicely structured books. And so to actually give you a better idea of that, let me switch my slide. So this is, very much the thing that I was inspired by, was the work done by Professor Cravella in creating this book. So this is a linear algebra book, right? And so it's all being done with Jupyter Notebooks. This is sort of his opening front page. And we go in and let's actually click on one of these. So here is a chapter on his, actually, something, on his linear, whatever it is, vector equations. Is that what I clicked on? No, sorry, linear equations, right? So his first chapter. And, first it just, it's pretty, it looks nice. And for those people who are going to actually be being taught how to work with Jupyter, which is actually not going to be the thing I'm going to focus on, but you could imagine that it's an obvious thing to teach somebody learning linear algebra to also see, kind of like learn the IPython that translates your ideas. But let's pick a slightly different one here. Where's the one on computer graphics? No, maybe I can't see it here right now. See if I pick another one that might have some. Okay, so this one. Sorry, I probably should have found one ahead of time. But what we could find here, for at least those familiar with Jupyter, there are also some embedded things where we could have like little interactive widgets so that we could actually play around with the equation and watch an animation change. Those can all be converted into the published book version. Okay, so, but with that in mind, I really want to point out, and I'm sorry, let me just move up here. I want to point out that one of the most important aspects is that Professor Cravella's book is all available to a student, all of it, not just the published version, but the source material, right? So here is the Git repository. And as you can see, he points out that in spring 2015, he started working on using Jupyter, sorry, not using, well, it wasn't necessarily Jupyter at that time, but IPython, and starting to build out to this book. And at the time he was using a traditional textbook, and these were, again, I'm paraphrasing Mark, but this was his way to start moving the students down to interacting with his material. And now he doesn't have a textbook anymore. His notebooks, right? All of his chapters are notebooks here. He's been able to remove the need for a textbook completely. And not only has he removed the textbook, he's also gotten it so that his lecture material and the textbook material come from this same repository. Okay. Now, I don't know if you noticed, I'll show you in the next little book that we look at, there was a Git icon on the right. Actually, let's skip back to, let's go back to the slides and then I'll do that for you. to get to mine. So this is now me, right? So I am now trying to build on what Mark's examples look like to go a little further and explore what can be done for systems. So here is, now again, this book is available, but I'll be the first to point out to you, right now, the textbook part of my course material is very lacking. It's just a little bit to prototype there. A couple of chapters are sort of real-ish that I pointed students at, but largely it's not really there. But what I want to point out to you, so here, so this is my book. Let's go under, so here is, you know, me walking through somebody, just a very, very gentle, hey, you know, we're about to learn about some Unix stuff and what the whole point was. Sorry, I did do that mistake again. But I want to point out something here about even this static version. So there is that Git icon, right? And notice I have, I have a repository, so I can click there and I'll get right to the source material of the book. I can open an issue with this page. I can suggest an edit. I didn't turn it on, but I can actually also turn on a feature that will keep a running commentary at the bottom of the page, which is actually hooked up to Git issues, so that you can actually see the evolution. Now remember, if we just think about Mark's book, 2015 to 2021, a repository is tracking the evolution of the knowledge he is offering. This is a powerful statement to make, that it doesn't have to be a simple cathedral. We can all communicate with each other. We can fork books, we can fork the material, and we can still show the ability to understand when there are contention over the material and improve it, right, as a community. Great. All right. So I don't know that this,
Jonathan, if I can just ask
yeah.
you a question right there. So, as you were showing us, I see that there's a lot of Git integration, which is great because you can sort of open issues, PRs, and a lot of open collaboration. But for you, like as a professor, what was the learning curve to sort of learn Jupyter books and Git? And what is sort of like some advice you would give folks, how easy or how challenging it is to sort of get into this sort of environment?
Well, certainly for me, I've been using repository control. I teach repository control. So certainly the aspects of Git were not difficult. However, I have certainly believed that if we're going to extend this world to, you know, professors across the domain, or not even just professors, who are going to be trying to contribute and build, you know, maybe humanities books, those are some of the things we're going to have to figure out. Now, I think there's been some very nice work that has been integrating Git under the covers for folks so that they're not quite aware. But those are all some of the things that I think is a challenge for this kind of approach. In terms of Jupyter, that was probably the thing I was least familiar with in terms of getting going. And to be honest, I have no clue that I'm doing anything sensible. I followed my nose and I hacked here and I hacked there. And these are all the kind of challenges that we're going to have to face, right? Which isn't particularly new for the open source world, right? We always sort of face this dilemma about how do we bridge the power of open source technologies and the lack, in some sense, of the corporate money that is creating the supporting infrastructure. But, you know, I'm thrilled to be speaking to a corporation that precisely has made its mission to change that, right? And so maybe, maybe part of this is my attempt to convince all of us that putting effort in refining and adding support infrastructure and adding the delivery technologies to this stuff could be really beneficial. Okay, so here's my repo. Now my repository is a little different. I actually generate textbook material, lecture note material, and lab material all from this repository because I actually have a very distinct separation on those pieces. But you know, it's a repository and it's got a README and it's got all the kind of stuff we'd expect. Sorry, I'm gonna go back here. Let's see, how am I doing for time? Okay, I better speed up. So I want to show you at least the other cool tricks and actually reveal what's actually you've been viewing. So first off, Jupyter is capable of providing a rich environment for presentations. So presentations and what we do is the backbone of interactive teaching, right? You can read and you can have lab manuals and that's all very important, but codifying and helping folks and giving them presentation material is really useful to ensure high quality interactive education with a guided expert. Now, I'm going to guess many of us have go-to PowerPoint, Keynote, Google Slides. But what's really open about those? I've been burned so many times in my career where Keynote has changed its file format. Google Slides, all of a sudden I find out actually Google Draw diagrams have restrictions. I can't even get to the underlying file format, which certainly makes it difficult for repository control. So that's, you know, already just an issue. But then what about the other aspects? There's really nothing fundamentally interactive about those technologies. They're not designed for us. They're not designed for us to deliver a presentation where you actually can have real examples in it. I don't want screenshots. So in some sense, I'm sort of also asking, where's the beef with that stuff? Like, where's the integrated computing platform that would let me as a presenter really do real work in an integrated fashion and can it so that others can build on what I've done? So Rise is a classic Jupyter extension which enables the ability to turn your notebook into a view that it's slideware, but it retains its notebook aspects. So let's see here, so with that in mind, I have, so that is what Mark does when he teaches. And I have adopted the classic thing with operating systems researchers. If I'm going to do every piece of my presentations in Jupyter, so everything that we're looking at right now is a Jupyter notebook. So if I click on this little X, this is the notebook we have been using. All right. It is completely just, and it's in a repository. As a matter of fact, the repository we looked at actually has this presentation in it. And there's nothing super fancy about it. And, you know, it's got speaker notes and all kinds of other stuff support in it. Let me just put it back into this mode so we can continue along. Because now I want to show you some things that make it particularly interesting, though, because it's not just about having an open source poor man's PowerPoint that's not quite PowerPoint. So first off, this output is a real live kernel, right? I have a real live Unix kernel beneath me running real live shells, like folks would be familiar with when doing data science, that your cells are live. But actually, I'm doing a little bit more than normal here. So you notice, I hope you noticed, right? I think the date and time change there. So I just re-executed that cell. And of course, I got a shell output. But, you know, this is a real Unix underneath it. So of course, everything is there, including my man pages and so on. So when I'm teaching someone something, there's no sort of, oh, this is sort of the slide. You can go open up my slides and use the environment that you're actually trying to learn about. Okay, but okay, so what? You know, I've seen executable cells before. But you know something? Your terminals are real too. So I can do all of the stuff I expect to do. Right? You get the idea. So I, in a lecture, can provide guidance, not just for myself, but all of this is codified. And somebody else who wants to try to teach this material, I'm suggesting this is a really good point to actually straight up go write that hello world with them. Don't just speak about it and let yourself make some mistakes. And when you compile it wrong, you get it wrong, let them see how it actually works. Encourage them to open up those slides and redo it for themselves, knowing that all the software underneath is sitting there capable of being real. Okay, so I personally was quite surprised by this. Now, in all fairness, it was a little bit of hackery to make some of this work, but anyway, sorry, I can't help but want to finish that example. We don't need to finish that example right now, so let me just continue along. You can't put me in front of a, you know, an Emacs window and not expect me to write some code. Okay, so now let me actually show you yesterday's lecture. So this was actually what I did in class yesterday. This is a slightly different layout. So here I was actually teaching, so again, this font-wise, you might have a hard time seeing this, so I really recommend try to make it as big as you can. But on the left is also Jupyter, right? But now I'm keeping a Jupyter lab session for those who know running. And I've got a terminal window where I've got Emacs running. I've got another window where I've got GDB running, and what we were actually doing in that class was I was showing how, this is my slides over here, how a system call can be done straight up in 3 lines of assembly code, and that you don't need, as a matter of fact, these binaries are compiled with no libc. I start the student at a Unix prompt building real programs with assembly code and slowly building our knowledge. There's the, you know, manual page for syscall. There's a website that shows that exit is 60. Here's some stuff that sort of explains what's going on, and here I'm doing it, right? I found this very powerful. Okay, so let's come back.
Jonathan, just to let you know that there's a lot of excitement in chat for this RISE package of Jupyter books. And personally, even I never knew about it, even though I have been using Jupyter books as well. So I think this is definitely really interesting. And it's a great way because we do a lot of presentations as well. And in fact, we're moving in that direction where we want to showcase everything via a Jupyter book. So, you know, why not extend it to all of our presentations as well? So I think this has given a lot of folks some ideas to get started with this. One question that I had was, I know that you're sort of teaching in this manner for the students. So are these notebooks also like easily shared among students? Do students sort of have a place to like just spin this up themselves? Do they, tweak it a little bit, provide you feedback, and so on? Yeah, just want to know how that sort of interaction goes.
Funny you should ask. So all of those things are true. There are some caveats. I'll spend just a minute on those because I actually want to show you that last trick is all about how to create on-demand instances where it's the Jupyter installation and everything else is actually coming out of a container, so that the lectures and the lab manuals and the assignments and the textbooks all integrate, and it's a click of a button for a student. And all of the presentation material, as I said, it's just a repo.
Yeah.
Okay. So in just a second, I'll get there. Let me just show two more little aspects that I found interesting. So first off, no big surprise, right? I mean, for anyone familiar with Jupyter, of course, my presentation slides have all the nice ability to have LaTeX and everything else in it. And again, anyone familiar with Jupyter and the ability to have IPython, hey, look, there is an example I'm working through with somebody. And of course, I'm a bit head, right? So my examples are using pandas in ways that are sort of probably not normative. So, hey, look, there's my example. Let's do or instead of and, right? And then let's update the output. And lo and behold, it's live, right? I could change my values, change my bit vectors. So I can also benefit as an instructor, even when I'm teaching something where I'm actually doing assembly programming, actually all of other Jupyter value, okay? But as Hema was asking, but what about, what about the lecture notes? How did they relate to the book? Well, they're, of course, just repository controlled, right? So like the book, I can have the source code for the book. I can have a static generated version, which actually has a link back to the source code as well. So if I'll try to do this quickly. If we come back to my repository and I go to the lecture notes, there's actually, let's see, yesterday's lecture was lecture, I don't know if it's gonna work here. Assembly programming. There's a static version. Here, I can click on the repository, and there is back to the repo, assembly, and there's the IPython notebook. But there's a better trick than that. Let's come back to my talk. And by the way, this talk itself, there's the IPython book for it. So I'm just not going to wait because I want to make sure that we keep going. Okay, so great. Everything is repository controlled. That was the static version that I published. That the static version they can look at on their phone, but at the same time, they can click and get to a repo. But here's that last trick. And here's the trick that I think all of us can participate in really breathing life into all of this, which is that Jupyter has supporting infrastructure that lets us, from the books, from a notebook, have containers spawned and launched automatically in a backend infrastructure. So Jupyter Hub is a layer on top of the Jupyter environment that allows, us to configure a world in which a user who wants to use Jupyter only has to have a web browser. They point to a Jupyter Hub service, and the service will spawn a container, well, authenticate them, spawn a container, and launch an image, start up a Jupyter server for them, and redirect their browser. So let's see if we can make all of that work. So, but before I get there, I want to point out, so those of you familiar with Jupyter, there's Jupyter Classic notebook environment, and then there's Jupyter Lab, which feels much more like a desktop. For those of you who don't know, this lab environment, right, let's see if I can click on it and if it works. This is what we were looking at on the left-hand side. Oh, maybe I have my first real bug. No, I don't. Or I do. No, I don't. Okay, so, you know, this environment allows a student, even though it's Jupyter, right, that I'm using, I'm not telling them anything about notebooks. I'm just telling them, hey, man, this is your ability to reorganize and start building a good old terminal environment. And in time, I can reveal to them less terminally things. Okay, so with that in mind, then, this means I can integrate in my book. You saw me every time there were some icons up there. I kind of avoided that rocket icon, because that rocket icon lets me then say, I've configured this book to this Jupyter Hub service. And if you click on this button, magic is going to ensue. Particularly, the user will be redirected, they'll authenticate, a container will get, you pick the container image, the book's content that I've curated very carefully so that you have like all this software required for doing assembly programming, all the way up to being able to write WebAssembly, is all inside that image. And it'll all get spun up and recreated for you. And the book's content will automatically get cloned into the container so that you can then also see the live stuff that I was working through. So let's, in this last, how much time do I have? How much time can I keep going for, Hema, and at which point should I sort of?
I think you're good, Jonathan. You can probably go on for another 15, 20 minutes, I would say, and then
Perfect.
Some time for questions.
Great. I'll be done, and I'll try to be done in under 10.
Yes.
Okay. So let's actually try this all out. So here's the real test for my demo today. So this, first off, is, we'll click on this repo just so you can see how the pieces work. This is a container image repository that I have sitting on GitHub, right? It explains that this container has been designed to be support for the textbook, lecture notes, and lab manuals. I tried to make it all friendly. It's inside a repo. And this container I build from this container definition. Sorry, let me just get back to here. And I publish on Docker Hub. Oops. Okay, I didn't put the right URL into my talk, but if you go to Docker Hub, you'll find that I build this image. Actually, let's just do it quickly. How hard can it be? How much can I screw up? Docker Hub. So remember, that repo was the definition for what, okay, never mind. Apparently I'm signed out of Docker Hub. Is the definition for the container. Docker Hub is a publish build of it. That means that all the binary bits are there to launch the container. Now, with the very kind help from the folks from Operate First, I should be able to click a button, get redirected to Operate First. Now, I've already authenticated, right? So I have an authenticated user on Operate First. There's my BU CS book image. And with any luck, so by the way, what you've been seeing to this point was up running on my laptop. Now what happened, the container's launched, the repository that we're working in is being cloned into that container. And there we go. So now the lecture, we'll call this a lecture, this talk has been spun up and the Jupyter service has been started in a container with my book content cloned into it and open that page. So if we go up here, we'll actually see that the URL is an Operate First URL. And if we now scroll down into a slide where I had the terminal, where did I have my terminal? Oh, sorry, I have to actually run this notebook. So let's run all the cells. So the cells are running. And let me just scroll down to where I have an embedded terminal just so I can prove that I'm not lying. Because I do tell my students every day that my job is to lie to them and have them catch me in my lies. Okay, so there's my terminal, right? The same terminal that you've already seen. But now I'm actually in the Linux container on Operate First. And the only state is the book repo that you saw getting cloned into it. So that's also very important, right? I'm actually going to switch back now to my other version, even though I guess we could continue to give the talk there. What's very important is that the container has been specifically designed to meet what I want to teach my students. It's stateless, which means that if they want stuff in the container, they clone it from a repository. And if they want to save their work back, they push it to a repository. The book, if they want to edit the book, they can, because I've included all the Jupyter authoring tools in that container. So if an author wants to use that container to just author, they can. That container is actually I'm going to switch over to the last slide for a second. This container, right? This is the piece of the, oh, is my mouse actually visible? I don't know if you're seeing my mouse move or not. Okay. Oh, actually, I forgot my other trick.
So,
Yeah, I know. I totally forgot. I have been spending so much time. So that's the hub, right? That's Jupyter Hub. That was the repo for the instance. It was built and put onto the hub. What we saw is that on Operate First, an instance was gotten from that. The book content got cloned into it, and then we were running. But actually, what we've been doing right now is the poor man's version, right? I've actually have a running container on my laptop, and we're working on the book there, and we're viewing it locally. I know that perhaps this is counterculture, but I actually think making sure we support both configurations is incredibly important. I don't want any lock-in, right? You should always feel free, if you can't get a cloud service, to be able to run this if you can. right? I don't want there to be formats that we're stuck to, but that means we have to evolve some of those formats. Okay, I promise I try to be done in 10 minutes. So let me just spend my last couple of minutes telling you, so everything we've seen, I've cobbled together. It's smoke and mirrors. And I haven't done any real work, right? I mean, I've just sort of learned bits and pieces and put stuff together and built off of the amazing work of others. But there's a long road ahead. I think what I hope I've convinced you is that there's real promise in breaking the proprietary nature of education. And in doing so, actually opening knowledge, right? Let's all remember, once upon a time, we were sitting in a classroom, right? Human knowledge as an academic, that's ours to guard and to make sure that it's accessible in a world to everybody. But that means making sure I can create and sanitize all pieces of content to be open source. There should be no proprietary formats. Now, for me personally, I got to get my textbook actually written. I've spent so much time getting all this stuff working. I actually have to do the work that I'm sort of supposed to be good at, which is actually authoring the material in a unique way. My lectures need to be edited, the lab manuals have to be built, discussion materials have to happen. I have to demonstrate and debug all my kludges. We have to take all of these things, as to Hema's point, and actually start having better people codifying best practices so other professors and instructors can do it. And now, to very near and dear to my heart, I am teaching a class next semester that's going to have over 200 students in it. I want to be able to have them benefit from clicking on a button and having a container running for them. That means this has to work at scale, right? I don't mind telling them, look, container might disappear. Your job is to manage your state. But I do need them in the middle of the night. I can't pretend they're not going to do this the night before the assignment. Have 200 of them inside their containers running infinite loops and fork bombs. It's just the way of the world, right? I mean, I want students to do that. I want them to do things like that. And so it has to work at scale. And this last point, we have to get demonstrations. Let me clear my drawings here. I remember how to do that. We have to get demonstrations that actually this can integrate into a full educational experience, meaning, so you've seen me use GitHub to manage the content. You've seen me use Docker Hub to sort of publish a container. And on demand, you've seen me use Operate First to use all that open source environment to make this actually a cloud service. But there's more that is also required to teach a class. I also have locally running at BU a Git service. We actually use GitLab for that one, where the students state for their work on their assignments. So while I believe in an open world, you also can't cheat on your assignments, and you shouldn't be handing your assignments away. And I need to give them the security of stable private storage. And so we have that. I also have instructor repos there. I have to make sure that it integrates with BU student records. And then I have third-party services I have to integrate with, like grading and classroom discussions. All of it relatively straightforward, but I still need to make sure if I want others to be able to do this, they don't have to like, oh, how do you do that? There has to be exemplars. Okay, Hema, I'm done.
Thank you so much, Jonathan. Just to add to that last, in fact, that was a question that I had, sort of, how do we want to extend this, like you said, for the entire educational experience, right? So do you see this being, used even for your grading assignments or the assignments submitted by the students, and effectively everything that goes on in a classroom, right? So is that sort of what you're envisioning that we work towards?
So there's several aspects to that question. To give you a little background on that, so if you look at Berkeley's Data 8 class, they actually, because they're teaching data science and Jupyter is their delivery mechanism for that, they actually have an entire assignment infrastructure built into notebooks and a grading infrastructure for it. Now, I have not looked at that in any serious way. Instead, I'm having students, so while I'm using Jupyter as a delivery mechanism, I still am having them write assembly source code, C source code. I'm having them take standard exams. I'm having them submit code to auto graders and manually marking their code. That's where something like a site like Gradescope, if there's time I can demo it. So what I do there is, for anything I do, I create a submission site there. I have my questions and my assignments in a private repository that's kept at BU because I don't want that leaking. And that I create independently. Would I love Gradescope itself potentially to be built on an open source technology? Sure, but I don't know what they do, right? But it is a very powerful tool as a professor having such third-party services. Similarly, Piazza was started by students because of a lack of good online classroom discussion support. And to date, I just use that because it's convenient. If there were other things, great. But those platforms actually I find very powerful and useful for me.
Yeah, okay. Got it. I see a couple of folks who are, I think, joining to ask a few questions. Nathan, if I'm saying your name correctly, did you have any questions for Jonathan?
Well, first, let me start by saying I'm awestruck, and just that whole session makes me want to go back to school again, just to have this experience. So thank you for what you shared today, Jonathan. But given, we're talking open source, we are talking about collaboration, and the last slide where you clearly pointed out, what this is just the beginning. There is a whole lot that remains to be done. I just want to understand. So I work with other educational institutions, from a Red Hat perspective in different capacities, and we have programs that do that. So, but at the same time, I want to be sensitive to this is something you have worked on, and kudos to what has been done here. So, what is the scope for increasing awareness about this technique in other institutions? I just want to understand what are the boundaries and be respectful of that.
So I think going all the way back to that first set of slides about the bazaar model, and actually the fact that I am not an open education resource expert. I didn't even know what's going on. I actually firmly believe in the bazaar model. I believe my job is to produce the highest possible quality content I can and make it available. And if others can benefit and replicate, then I want to encourage that community. Now, in terms of my assignment infrastructure and so on, great. As a matter of fact, if a professor emails me, I'll say, cool, you can have private access to that. Just please follow these best practices around them. I don't think most professors don't have any desire to destroy the private components, but I'm really trying very hard. And this is, the kudos to Red Hat to power everything through open source material. right? And which means the only parts that if there's some piece of content that I really don't want leaked, fine. You know, I'm careful about that. Like student identity, I can't leak that, right? I can't leak their grades. I can't leak those things. But the meta, I'm hoping what I'm doing that others will look at and go, oh my God, what a steaming pile of crap. This is the right way to do it.
Yeah, can I jump in for a sec, Jonathan? So, I mean, I'm come back to academia teaching operating system course, and it's just like, I want to rewrite a bunch of chapters, but I can't. It's a static textbook. So just to make sure, I'm not sure everybody's aware, what we've been building here, ORCI, Operate First, this is an environment that's available right now to Harvard and BU, and it's going to be available to all the institutions in the Boston area. And then there's actually this Commonwealth wants us to extend it to all 500,000 students across the Commonwealth. But everything we're doing is open source. Everything we're doing is replicatable with the idea that we're going to automate it enough so other people and other institutions can actually do this stuff on top of it. So I actually think this has a chance of, you know, building that same culture where I could go to a textbook I don't like, I can change a chapter, I could replicate it, or and I can give a pull request to the person who did the original work to see if he wants to integrate it. Right now, I would say that a lot of this stuff is incredibly fragile. It takes somebody with Jonathan's ability to do this. I think this is a huge opportunity for us out of what we're building with this open source technology. But a lot of this stuff will take, you know, effort to actually make it solid enough, even so that other CS faculty could do the kinds of things that Jonathan did, let alone the grander opportunity of people, the humanities, being able to do their work this way. But I just think it, you know, if you look at what you guys have learned in the open source community about that ability of the community being able to work together on studying, I think this is the start of it. And I think that's why Heidi and I thought we wanted Jonathan to present to Red Hat, because I think it should be right in your ecosystem.
Yep, Marcel, if it's okay, I just want to ask another question, a follow-on, and it is sort of related. From a Red Hat perspective, so this is possibly the finest example of how we work with academia, Jonathan. But we have another program called Red Hat Academy, where we actually bring curriculum for the students, and then the faculty can actually have instructors trained on that, and then they can deliver the courses to the students. Where I'm coming from is, I know for sure that there is no Jupyter notebook, the mechanism that you showed in that curriculum. It is the traditional curriculum the way it exists. I'm thinking that, hey, we are working in two different capacities, and what if we kind of make that curriculum active and interactive and make it even more exciting experience that this has the potential for. So it could be a project that serves the institution and as well as one of our own programs. That's kind of where I was going.
I think it's absolutely right. And I think even further, I mean, how many of you guys have authored presentations in Google Slides, right? They shouldn't be. They should all be, you know, all presentations should be done this way. It takes a lot of work, but it's
Please
work.
don't blame me when you're up in the middle of the night.
Yes,
there's still work to be done.
and I totally second that, because this is also what Operate First is about, having live running demos of stuff that is continuously evolving. And you just applied that to educational content. So having it live there with a history of how the content evolved, how your material evolved, and for everybody to replicate in a really easy way. And I'd like to take on what Oren just said, that this is currently really fragile, and you want to make it available to people that don't have the wits and this arcane knowledge of a bit head doing stuff on the command line. And if you allow me to share my screen, real quick.
Just Marcel, I just want to add
Yeah.
to that, for a sec, but not just Academy be built using this, but in fact have it so that faculty members can actually issue pull requests to courses
Yes.
to make suggestions on changes.
Yes, and this is the latest and greatest thing that we built out of the Operate First community to make it really easy to deploy Jupyter books. So you can just paste your GitHub repository in here and you select whether it will be deployed as a Jupyter Hub thing and as the Jupyter book website. You have some stuff here explaining how it works. And then you get this thing created. Like here's one that has previously been built. It's built from the same Git repository that Jonathan just showed. And I can launch this thing as a website where everything has been pre-built, or I can launch it as a Jupyter Hub where everything has been pre-selected and you spawn exactly this thing here. And I tried Jonathan's repository. So if I go back here and I deployed under the covers, it failed, unfortunately, but it's really easy to go in there and see why it failed, because I can click here, show me the details, and I'm being dropped into the build pipelines that did all this building. Go to those failed pipelines here, click this button, view logs, and then I see it failed in this generate step where it couldn't find the table of contents file. So it gives you immediate feedback to what are you doing wrong here, and you don't have to learn all the things, but you can go straight into the publication content process.
That's fantastic. Certainly, it would be great for me to spend some time seeing how all of this works, because I think, you know, the more we can do to make this automated, the more we can do to take the process and make it so much easier for folks, but still keep it transparent enough that we can get to the bottom bits and fix when we can. Worst case, then, of course, then we have proper support lines for it, right? You can always now have a support channel where the person on the support side know, hey, could you please click this, or let me replicate it and let me get to the details, which is what's going to be necessary, right, to get an arbitrary professor to use this. Actually, can I share my screen one more time? Because there's actually dovetailing on that is something I want to point out that has been a real challenge with respect to the open source portion of the material. So one of the things that we are infinitely up against is proprietary content, right? It turns out that one of the things that I got stymied by is drawing programs. So the inability to have really high quality open source text-based repository controlled drawing was incredibly difficult, let alone the cutting and pasting of, you know, clip art like material. So I just want to point out, so I'm inside a Jupyter environment here, right? And actually, this is a set of drawings. So the beautiful thing about these kind of evolving platforms is that we are moving to enabling lots of people moving towards integrating, for instance, so all the drawings that you saw on all my slideware in this presentation is actually all done with non-proprietary file formats that are all repository controlled and are even moving towards their ability to be integrated into an interface like the Jupyter interface. Now, as a matter of fact, you can see that it has some bugs in it compared to the version I showed. That just happens to do with the UI that's currently not parsing it fully correctly in Jupyter. But we are moving towards the possibility of ensuring that even those kind of things that have been sort of the stranglehold, like high quality visualization, that things that actually Jupyter notebooks aren't particularly good at are coming. Sorry, Marcel, I didn't want to take away from that, but I just really want to point out, I need help with this stuff in actually even, for instance, redrawing textbook material.
I did have another question, but Hema, I want to pause if somebody else does.
I just want to tell Jonathan, there's a ton of chat discussion, which I'm sure you weren't able to see because you're actually giving the presentation. But I think that maybe it seems like a lot of parts of Red Hat are interested in this, or a lot of people are interested. I mean, should a whole bunch of people just contact you, or do you want them to reach through Heidi and kind of come up with some coordinated thing? I love Jonathan, but he's not the best at email, to be honest. In fact, he loved it when his email didn't work for 2 weeks last month. So Jonathan, I just want to give you that.
Yeah, certainly I think the best thing to do is for us to figure out a coordination mechanism, because every time I open up my desktop and my students see that I have over 44,000 unread emails, they're very quick to realize the first thing is not to send me email. So I think we can certainly coordinate that. And the other thing that's sort of figuring out, like for instance, for me, this is unfortunately not my day job, right? So it's hard to figure out the right way to, like, I run into various problems, and knowing that there's a community of folks now, it would really figuring out how to logistically deal with that would really help me incredibly.
Yeah, definitely anybody who wants to follow up either on participating on a separate project using this idea or contributing to what Jonathan's doing, feel free to contact me, hdempsey@redhat.com. There's also a link on our website so that people who don't happen to be here and don't know how to email, people who are students right now, some of them never use or read their emails. So there'll be other ways to contact us through the website if you need to. But we'd love to have people participating, and we support students working on this through the Collaboratory and through Red Hat, and also Red Hat employees and people from other academic groups who want to collaborate. It's all great.
Yeah, I think that one thing I should say from what I've seen Jonathan struggle, the number of 3 a.m. emails he sent me, oh my God, I just got this working, is that I really think it's important. So you only get to make a first impression the first time, and saying that any of this is ready for prime time is, I think, clearly not the case. I think that it'd be good if, like, if Marcel was talking there about having this grow as operate first thing to help people author these things, working with Jonathan as exemplar. Maybe we pick 2 or 3 other textbooks or ideas of courses we want to target. And then when it's a stable enough environment, making it a broader set of invitations for faculty to develop their stuff. I
don't know how much I love being the one who says, come everyone, and Aran is the one who says, but don't really expect it to work.
It's just,
we usually have the exact opposite roles.
I know, that's so funny.
But actually, with that in mind, I think there's a really, so for instance, I am trying to address a need that I just have, right? Like, I mean, I have to run this course. It's very difficult for me to put all of this effort in and not be able to translate it, for instance, in next semester's class. I can only push so far off trying to use this stuff at scale. And so certainly for me, I don't mind being the guinea pig, because I've sort of put myself in that position. But running, so one of the biggest values of this approach, it's incremental, right? I mean, that's the value of the bazaar. We can all sort of evolve it. But there are points where I am now will try to be the first one to try and run a 200-person class this way. It sort of puts me in this sort of compromised, unique position. So yes, Ron, it doesn't work, but it also has to work, like, right? And if we really want this, and so some of that, I'm happy to debug. I will spend the time, but I need to know that I can launch 200 plus containers with infinite loops in them.
So we already also did at DEF CONF US, we did a workshop using Jupyter books, having 20 participants using a similar environment, and it was all deployed via this Meteor interface that I just showed you. And as a matter of fact, all of my team and our extended team is using this pipeline to publish AI and also SRE content. So you're not the guinea pig anymore. We have folks around this pipeline to build those books and deploy those containers into Jupyter, make it really easy so that content creators can focus on creating content, and having those two GitHub repositories around Meteor to file bugs and work on the bugs so that pipelines work as expected and so on.
Yeah, it's interesting too. Like, for instance, in the semester, like the class I'm teaching right now, which I've got like 12 or 13, and maybe it's 20 students that were sort of playing with this stuff. And it was actually just this last week that I had them switch over to trying it on Operate First. To be clear, for those students, oftentimes when they're using the container at this point, the book content doesn't matter, right? That's actually, what they're doing is an assignment. They're using it as, they're simply using Jupyter as the desktop environment for that container. And for me, and I can, as I said, I can train them to understand that their storage, I want them to treat as ephemeral. And I actually don't want them to have permanent storage. The bigger problem for me is just what happens when there are 200 using it as effectively their place to do their assignments. Not so much even the building of the book, because I actually sort of need to keep that a sort of a very tight workflow, which is fine, but it's only me right now, and that's okay.
Yeah, I think there's a bunch of things, Marcel. I think that on the one side, and I mean, I'm super happy you guys sort of have been starting to build this out, but I think there's the stuff of whatever customization we end up doing to OpenShift to better support this stuff. But then there's the stuff we do to help build it. There's also a huge number of tricks that I've seen Jonathan employ to do various things so that he could author his content. Where, you know, somebody has to write the book on how to write the book on this stuff. You know, even the separation of lab content versus assignment versus the presentations, you know, and then as this evolves, because frankly, you know, the separation GitLab and Jupyter Lab and the classic and stuff and what works in each, these, yes, there has to be mechanisms to translate things, because once somebody's invested the time to develop something with one set of tools, and then, you know, this platform is changing, there has to be ways of converting it. You know, I refuse to use certain tools when my stuff broke after at a critical time because they submitted an upgrade. So I think this is all new, but I don't think we're there yet in terms of throwing this open to 100 faculty to author their books on this. It's nowhere near there yet. But I think if it does happen, not only is this going to transform in education, but it's going to be the underlying platform. Like as Jonathan was saying, this ties into the repository control, the grading and everything else. I mean, every university will be than authoring stuff this way. And I firmly believe textbooks written this way will become the dominant kind of textbook because a community can evolve them. So, I mean, just imagine OpenShift in every academic institution in the country. That would be pretty neat.
Well, it looks like the questions are winding down. Technically, we're at the end of the talk. So if no one else is going to join and ask more questions, I think we can close this. Like I said, we'll post the video. I want to thank you, Hema, for coordinating the conversation and working with Aran and Jonathan ahead of time, and working obviously with the Operate First folks in the AI COE as well. Thank you, Jonathan, for a really inspiring talk. Got a lot of people very excited, and we'll definitely be following up on this. And thanks, Aran, for setting it all in context and being the voice of reason.
Someone's got
Something wrong when I'm back.
We'll have another Research Days event next month. Talk to you later. Bye-bye.
Thanks,
Bye.
everyone. Thank you, Jonathan.